All right, well, thanks again for everybody for being here today. We appreciate it. Actually, I was going to give a shout out to somebody, but it looked like you left. And that was going to be to Mr. Rick Ridgway that sits right up front here. His organization, they said they have a travel restriction, but he came here anyway. He funded his own trip from Lyle, Illinois to be here. So when he gets back, if you see him wearing a Hawaiian shirt, well, we appreciate him. So, we appreciate everything he does for us. A couple quick things about our presentation today. So as you see, our title is Cycles Composer and the Continued AI Strategy. This originally started out as two different presentations, but because the content is so similar across the two different presentations we were going to give, we decided to merge our efforts into one. But with that said, kind of focusing on the AI aspect of it, this time last year, if you were here, you saw that there's this big wave of Gen AI technology rolling in. It's very disruptive to your organization. There's a lot of changes within our tool set that we were trying to show. And I'm going to continue to show some of those Gen AI the features in our tool. But one of the things that we also wanted to focus on and I wanted to talk about was I didn't really have a good spot to put this, so I put it right at the beginning. And that is the stuff you're going to see today for all of our customers that are on a SaaS implementation, so you're on our cloud. If you want to turn on the AI features, just let us know, and we'll turn them on. And I wanted to provide a little bit of information about the environment you're turning on. So when we turn on our AI systems, our Gen AI systems, one of the things you're going to see is we are now using Amazon Bedrock services. And the reason we did that, we switched from our original architecture last year to Amazon Bedrock because it gave us the opportunity to utilize all the latest models. So all the latest large language models are available to us, and we can switch in and out of them at will whenever we want to. But it also provides all of the IP and security that we needed to make sure all your data stays secure and stays isolated. It's secure. They don't use your data to train any of their models. And so it just made sense for us to switch into this type of environment. It also gave us a bunch of opportunities to put in guardrails where we needed. When we start adding different modalities into the tool set, we have the ability to scale up into different modalities as well. So again, if you don't have your AI features turned on yet, just let us know, and we'll turn on those features in your environment. Now to that same point, we also have customers that are your installation is all on premises. You own your installation. And as we go through this, you're going to see a lot of AI tools that you may want to take advantage of. And we've worked with some of you to create your own internal AI infrastructure that you can turn it on, and it works within the tool. But I also wanted to point out a couple things. Like the architecture I'm showing here, this was just what we did last year. And we've had a lot of questions recently on whether or not we can point our AI system to an AI system that you already have internal to your workplace. And the answer to that question is yes. We can change the endpoints from our AI endpoints, our large language model endpoints, to yours. So if you have a system in place, just let us know. We can work with you to get that connected. As well as some of you have asked, well, we don't really have a good one in place. Can we take our on-prem installation and point it to your Amazon Bedrock services? And the answer to that is yes also. So as we go through this presentation and you see these new features, if you want to implement them, we have a variety of ways to get those features implemented into your tool set, and we can customize that as needed.
All right, so I'm sure a lot of you are actually very familiar with this already, but just for the rest of this presentation, we wanted to take a minute and really talk about the three different flavors of AI. When we say AI today, I feel like in the colloquial zeitgeist, everyone thinks of generative AI, but there's really three different flavors. The first being symbolic AI, and that being defined as rule-based reasoning using explicit symbols, and it models logic and knowledge declaratively. And the interesting thing about that definition of symbolic AI is Auros IQ has been doing that exact thing for about 15 years now. So all the features that you guys are already using, they are in fact symbolic AI per that definition. And so without knowing it, we were an AI company for a very long time now. Generative AI, of course, is learning patterns from data to produce new content, and it lacks explicit rules or reasoning. And that's the functionality that we've been focusing on a little bit last year, and we'll be talking a little bit more about today. And then the final one is agentic AI. That's really starting to build a lot of momentum in the industry right now. And agentic really combines the two together. So it takes that reasoning and that learning and action to achieve a specific goal. It may use symbolic AI or it may also use generative AI together. And that's where a lot of the new stuff that we've been working on is in that agentic space, which is exciting. So we want to touch on a few things that Jeff talked about earlier. The first being that performance aspect of generative AI. We've really been thinking intently about our strategy of how do we ensure that for highly regulated spaces, where the integrity of the work has to be right engineering. It's very critical that you don't get hallucinations, that you don't get incorrect answers. How do we make sure that that performance is where it needs to be? And so there's really 3 different techniques for that. The first would be to tune or train your model. And there's some real downsides of that. It's very expensive, it's very time consuming. And it's done with stale data, right? As soon as your training of that model is done, the data that was used to train that model, you can't keep adding to it, right? So whatever training was done, that data now becomes stale. It's not current with where your organization is today. It also produces model lock. Once you spent all of that time and energy training your model, you don't want to move to a better model potentially, even if it becomes available to you. You also have issues around IP retention, right? That the model might hang on to some of that company-specific information that it was trained on. And you still get unpredictable results. And then the last thing being, if you want to go and make additional improvements, you're going through this bottleneck of a programmer, right? That training of a model has to be done by a programming team. So it can't really be affected by the people actually using the services in real time. The second approach is a text-only data pipeline. So that's taking any of your existing information that's digital, whether it's on a SharePoint, whether it's in a shared drive, and pointing your generative AI at it through some prompt engineering, saying, hey, go reference this material to give me a better answer. And so, again, there's some challenges. You do need some lightweight prompt engineering to go with just typing something in a chat box. But also you tend to still get poor data quality and applicability because it's up to the generative AI to determine whether any of those reference materials are applicable to the question that you're asking. And it often makes mistakes when it's answering that question. And it often can misinterpret the reference data that it's using because it's not discrete, right? It's in text format. And so the third approach, which is the one that Auros IQ is taking, is a symbolic AI data pipeline. And we talked a little bit about this last year. That does take, again, some robust prompt engineering, which we've been doing some really exciting innovations in that this year. For me personally, that's been really exciting to learn about. But then also, you are able to life cycle your pipeline in real time, right? So as data becomes obsolete, as data changes, the people actually owning that data and using that data, when they change that life cycling in real time, the prompts that are being run are always referencing whatever that current state is of the pipeline. You get complete and robust intent and captured in that reference data, right? Because again, it's discrete with the symbolic AI, and that results in very predictable results. And then last but not least, you can iterate on the results improvements. You can improve the performance of your AI just by improving the data in your pipeline. It doesn't take any interaction with a prompt engineer or with a programmer. You can affect the performance of your model in real time. The second point that we've been spending some time trying to figure out a strategy around was also something Jeff brought up around transparency and traceability. So that black box that sits between your inputs and your outputs. And so we asked ourselves the question, if we really want to leverage generative AI, if we really want to be able to use its results, we have to be able to answer that question, is the result trustworthy? Where did the result come from? And so all of the features that we're putting in place with agentic, and we're also starting to work some of this into the generative features as well, we're really producing two outputs. The first being the results to the question that was asked, but the second being this group down below. So the reasoning and assumptions that the generative AI did in order to produce that result, any concerns and contradictions that the generative AI found while it was producing that result, and then also very discrete labeling on any content and any activity that the AI took, so that you have that traceability of what was generated by a human and was reference material and what was generated by an AI. And both of those things, the result and all of this transparency information, get presented back to the user. So this idea of human in the loop, right? The subject matter expert gets to look at the result, gets to look at all of that supporting information around it, and they now get to make a decision. They can review it, they can edit it, they can approve it, they can refute it. And again, importantly, all of those activities, the changes that were made by the SME are labeled as activity that was done by the SME versus the activity that was done by the AI. So now when you incorporate whatever activity that's been done or whatever new content was created back into your symbolic AI data pipeline, you have that traceability of what content and what activity was AI and what content and what activity was human.
So we've talked a little bit about strategy, where we're going, some of the things we're concerned with, our reasoning for going different directions. I kind of want to set kind of where we're at and identify what are some of the existing technologies that's in the tool set now. And so we kind of laid out, there's the different types of AI. And if we look at the symbolic version of AI, we've had this in the tool set for quite a while. So things like vitality, the ability to measure the confidence and the quality of the knowledge that's in the tool set. Our modeling engine also uses AI functions. Our process models, our model tables, right? Those are all machine learning type of AI tools. Our proximity search, we use latent semantic indexing for a long time now. So it learns and it can identify similar items, knowledge items within the tool set. And then last year we introduced this concept of some of the new generative AI features. We talked about this tool set we called Search, Find, and X, the ability to use a natural language prompt to find knowledge items within the tool set. And then also the ability to assist authors that are creating this new content and putting it in the repository and providing them with a tool that does AI write assist to help them make well-formed, captured knowledge assets that they can provision into other workflows. So just a couple quick screenshots kind of point out what those are. So if you have AI turned on your instance, you know what this is. There's a little search button right on top of the Auros banner there. And what that allows us to do, it opens up another window, and you can put in a natural language prompt. And that prompt goes across the knowledge packets, your assessment controls, and any issues you have within the system. So based on that prompt, it finds relevant information, brings that back to you. You can continue to refine your search and kind of get down and narrow it down to items that are important to you. And then there's also an option to build an AI generative summary on that information that you have in your grid. And this is the current functionality, excuse me, and we're continuing to build on this functionality. We've gotten a lot of good feedback from all of you that have turned it on what you'd like to see improved, and we're working to implement those new changes, and I'll talk about those at the end of this presentation. Also, like I mentioned, for authors, so inside of a knowledge packet, so there's an example of a knowledge packet that is being authored, and in the description field and additional information fields, there's the ability to put in text into those fields, and then enable the AI features. There's the AI button in the upper left corner there that allows you to refine the content of that text and use Gen AI features to improve the text to make it better to deliver into your process.
All right, so what we currently have in development, this is currently at minimum viable demo. It's to the point where we're now starting to do some pilots, which is really exciting. But it's predominantly in the agentic space, and it's something that we are calling Cycle Composer. Cycle Composer is really bringing together 3 different key functionalities that all have an iterative process. The first one being ingestion, so bringing new knowledge into the system. The second one being attribution, where you're taking existing knowledge in the system and you're attributing it outside the system, so back to an authoritative source or to another source somewhere else. And then the last one being learning. Learning cycles have actually been in the product for some time, but they were only using symbolic AI. We're now migrating them over to agentic AI, and will eventually be folded into this larger feature of Cycle Composer. There's a whole bunch of functionality that comes across all three of those features that also might be then incorporated into some other places that Steve's going to talk about. And this is not an exclusive list, this is just some examples, but it's AI proposed modularization, classification, parameter use and creation, model use and creation, attribution proposals, and then obviously learning proposals. So as we've been working through developing these new feature sets, we've really been looking at two use cases. So the first one I'm just going to touch on very briefly, and again, this is something we'll be talking about in more depth in the presentation with Spirit Aerosystems, but that's model-based specification compliance. And so we've been doing a lot of pain points with the aerospace industry, mostly because there were existing projects around this topic, like at Spirit. And also we're currently almost finished. They're in the evaluation stage of a pilot with the Digital Standards Alliance. That's with SAE and ASTM, and then a whole bunch of aerospace customers. And you'll actually get to see some of the results of that pilot today in some examples. And then we've started to do some customer pilots as well to validate that we're heading the features in the right direction, that it's solving the problems that we need it to solve. The second use case we've been focusing on to really make sure that, again, this is doing what it needs to do is the requirements management. And the specific use case of requirements management we've been focusing on, like Jeff said, was in Tier 1. So we've put together what we feel is a pretty comprehensive list of the Tier 1 pain points with this use case. We conducted a think tank earlier this year that was highly successful. It gave us a lot of feedback on tweaks to make in the strategy and the direction we were making, and then how to lay out that strategy for development on future features. And then we're also now starting several customer pilots, which is also very exciting.
I want to describe a little bit about what requirements we're talking about. I mean, just the term requirements in some circles, that'll start a fight. I mean, it means a lot of things to a lot of different people, and it's no different in this room. But when we talk about requirements management, there's certain requirements that we're talking about in particular, and Jeff kind of laid that out earlier, but I just kind of want to reiterate some of that stuff. So the way we see it, there's four main types of requirements that groups try to manage, and some groups try to manage within Auros IQ, and some do it well, and some struggle with it. The first one, if you kind of look at either end, there's two gray boxes. We have greenfield or non-recurring, initial product development type standards and requirements that need to be managed. And at the far end, we have software requirements, which are also tend to be non-recurring. Now, because they're non-recurring, it doesn't make, Auros could manage them, and some people have tried to do it, but there's not as much value in putting non-recurring requirements inside of Auros IQ. But where we do provide a tremendous amount of benefit are the two in the middle in the orange. And I want to describe those real quick. So the first one we call externally authored. And we've heard a little bit about this one, especially talking about Tier 1s that have to deal with these type of requirements a lot. And these externally authored ones tend to be a flow down of requirements from either the customer or a regulatory body that provides the information to the manufacturer. And what they tend to be, right, is they tend to be requirements for a particular project, but they're recurring. They tend to be the same requirements over and over, but specific values for that one particular project. But because of the nature of them being recurring and reusable, they fit really well inside of Auros IQ. And so oftentimes, especially our supplier base, our Tier 1 suppliers, they have to manage this information. As well as the third item in here is internally authored, right? And these are the requirements that individual organizations build for themselves. These are the things that their best practices or items that they've learned over time that they do in order to make sure that they are meeting the requirements of the externally authored items. And not only do they have to manage the internally authored requirements, but they also have to understand, which externally authored ones they align to, right? Where they have coverage on the externally authored items. And it can become a challenge. And we actually heard of that challenge. Terra mentioned that we had a event this past August where we invited several of our Tier 1 supplier customers and to talk about them. And the list of pain points they came up with was this. They often get the same requirements across a vast amount of OEMs. So Jeff mentioned Adient that said they have 27. They're getting those same requirements, but they're getting those requirements across a variety of different documents. They're putting them in different tool sets even sometimes that they have to manage. The other thing that they said was, we spend a lot of time managing these external requirements and trying to align them to our internal requirements. It takes a tremendous amount of time to do that, and where they're looking for a better way. So they also mentioned kind of what Jeff was mentioning about Excel. They oftentimes break down the external standards into Excel files, so that way they can provide evidence that they've met the requirement and they have traceability of compliance to those requirements. There's a lot of time breaking that information down so they can just be delivered back to the customer as proof. One of the other things I think this one is really important is that they have no systematic way to look across all the different requirements they get from all the OEM bases to see where there's alignment. And it's really difficult to identify when one single requirement satisfies multiple customers. So we're looking at ways to improve that for that group. And then this one is just maddening for them, right? They do all the work to break the requirements down. They align it to their internal standards just to be delivered a new revision of requirements that they then have to understand where those revisions within those requirements are applicable into their process and make those changes.
So this is a visual representation to kind of get at those pain points, but then also the model that we're trying to migrate to with these new feature sets. So you can see here, again, you have those either internal or external specifications, and then you have to align those to internal policies, right? The internal policy being how your specific company is going to manage or execute on those requirements or comply with those requirements. So you have this very manual and cost-effective and error-prone process of constantly connecting or mapping between those two different discrete items. And every time anything changes on either side of the equation, all of your linkages get broken and you have to start over. The model that we're migrating to, and you're going to hear about this some more in the next presentation as well, is to actually flip the script and go the opposite direction. All companies that we've encountered in any industry already have these internal policies in place because they're operating today. And so if you build those policies discretely in a model instead of in misinterpretable text, and then you look backwards to your specifications and you say, hey, let's go find where in the specification our internal models have coverage and where we have gaps. This becomes a much easier activity, a much more automatable activity. Is that a word? I think that's a word. And these connections can be persisted and managed, so you can life cycle these connections, right? When something versions on either side of this equation, you can version that attribution. They're always referenceable, they're always live. You can have multiple versions of them with different applicability. And so this becomes something that you iterate on over time rather than starting over every time from scratch. So we're gonna look at, in a little bit more depth, how you would actually end up doing that. So this is really the model for what the overarching activity would look like, but also it's going to help you understand where Cycle Composer sits within this activity. So you start with an authoritative document, whether that's a PDF or a Word document or an Excel file, and you got to bring that into the system. And so this is our first cycle in the Cycle Composer. We call it an ingestion cycle. And it's really just about importing, right, and unitizing that knowledge into these unitized packets, which we call knowledge packets in Auros. Next, though, you have to take it to the next level to really make it usable and actionable, and that's where we're modeling things, right? And that's where I think anyone who's gone through this process would tell you that's the hard part and the most time-consuming part, and the part we're hoping to help with the new functionality that we've been developing this year. So you're really codifying that knowledge with that no-code modeling framework that Jeff was talking about earlier today. And then once you have those models, you have to provision them for reuse, right? Whether that's in production development or in a manufacturing space. And when you do that, you need to be able to persist and report that data out to have proof of compliance. But once you've done all of those things, in order to continue improving, you need to learn from what's happened. And so this is where learning cycles comes into play, where you take that execution of reuse and you learn from what happened, and you now can continue to curate your existing models. You can refine them, you can improve them, you can life cycle them. And those models, you have to be able to trace back to our authoritative documents. So this is where the attribution cycle comes into play, where we're constantly looking backwards. Anytime there's a change, whether it's a new KPAC or an iteration on an existing KPAC, we got to attribute back to the authoritative source to say, do we still have coverage? Have we fallen out of compliance? Are we exceeding compliance, et cetera, et cetera. And then last but not least, sometimes we have to be compatible with legacy systems that can only interact with PDFs or Word documents, right? The regulatory bodies sometimes will only accept a PDF as proof of compliance. So we always have to be able to recompose a document out of the model-based knowledge base. So Cycle Composer is really on the upper and lower arrows here. It's these three cycles. It's the ingestion cycle, and then on the lower side, the learning cycle and the attribution cycle. So we're going to go one layer down and really see what do we actually have to do to go about doing this. And so the colors line up here, yellow being our first cycle, green being in the middle, and blue being on the end. And the first step is to modularize. You got to break that down into independent pieces. And again, we're going to get into this in a little bit more detail in the next presentations. I'm going to kind of speed through it. But then you got to classify those modules. You got to parameterize your variables that need to be executed within them. You then build component models out of those variables, which we call parameters. We then group those models to what things have to be evaluated together and which things have to be evaluated in sequence. Where's the precedence? Where's the conditionality? And then all of that model, that conditionality, that precedence, that gets modeled into what we call an orchestration model. And then finally, as you perform each of these steps, you learn things about the steps that came before. And so this rationalized step becomes really important, where you're iterating upon the things that came before to make it work better and better. And then you instantiate for reuse. And you always have this backwards looking cycle of where we need to make improvements moving forward. So let's talk about where the new Cycle Composer functionality is currently in this model. We're developing it along that same framework. So we started with modularize, and we're going to see a live demo here in a minute. But we are now successfully with an agentic AI feature. We've had multiple successive tests of modularizing. We have also successfully had it classify. So it's looking at the existing extended element ontology that is defined in a community. Based on that and the source document it's been provided, it's proposing values to populate. And then it will also eventually be proposing ones that maybe your community of practice is missing that you should consider adding. And then we are also now to the place where the AI can propose parameters. So it can look at existing parameters in your system and say, hey, this parameter is applicable to this knowledge. You should reuse the existing parameter. Or no parameter exists. I'm going to look at the patterns that you've already defined in creating your parameters and propose a new parameter with definitions and units and kinds and all that goodness that you need to actually build a model. The next step that we're currently working on is having the AI actually propose your first draft of a component model out of those parameters, and it's actually really exciting, the results we're getting out of that already. But not quite ready for customer pilots yet on that fourth step. And so after that, we'll be moving on to grouping, orchestration, rationalizing with learning cycles, and then deployment.
So I'm going to jump out of presentation mode here, and we're going to do a live demonstration. So yeah, again, this is a demonstration that we're going to go over. We've mentioned this thing, the Cycles Composer. We've talked a lot about what it is, and I want to provide a much more comprehensive look at what it does. So we're going to jump into the tool and we're going to look at it in terms of what it does. And again, this is in regards to requirements management, model-based requirements management. So to kind of get things started, if you kind of go back to what Terra showed, there's those 3 circles, and we had the ingestion cycle, an attribution cycle, and a learning cycle. And I want to show all 3 of them to you today, and I'll kind of go through each one. But to kind of set it up, we have to understand where we're starting, and that's with the ingestion. So when we talk about ingestion, we're really talking about bringing an analog document, based set of requirements into the tool, right? That we can then model, and then we can do all the attributions to, and we can get all the model-based cognition goodness out of the system. So for today, kind of set the foundation, I'm using this document, this Kelsey Motors Inc. It's a great company. They do tremendous work. And they need a power sunroof. And an organization, this fictitious one that I have, it creates these power sunroofs. So if I look at this document, it's a typical requirement document that you might see from an OEM. And what I want to do is I want to ingest it. So instead of breaking this down, going through one by one, copy paste into an Excel file, I want a tool that can decompose this for me. And that's where the cycle composer ingestion cycle comes in. So if I get out of this, what I want to do is we're going to hop into Auros IQ. So you're looking at one of the pages of Auros IQ here. And I'm going to go up to my attribution cycles. So if I want to run that document in, what I would do is I would create a new ingestion cycle, give it a name, point to the file I want to ingest, tell it which community I want to ingest it to. And that's because, as Terra mentioned, the AI can detect the metadata elements of your community, and it can also predict the items in the document that align to those metadata elements, which is really important for the part of the cycle where we persist that information into the process. So this identification of a community is really important. Now, I've already done this, so I'm not going to fill all this stuff out. We're going to look at my example of an ingestion right here that I did a couple days ago. And what you're going to see is what happens after we run the cycles composer through an ingestion cycle. So my community practice didn't have any KPACs in it, so this is a complete ingestion. So if I kind of scroll up, you can see there's my document on the left-hand side. And if I scroll through and I kind of get down, I can see now that some of my document has been highlighted, and I have this area in the middle now where the AI Cycles Composer tool set is starting to propose different types of knowledge packets that I may want to create in order to apply these requirements into my workflow or my processes. What it has done is it's already categorized this information for me. So if I look at each one of these items here in the middle, they have a tag. This one's informational. If I go down, it's identified this one as being a requirement. So there's different kind of informative tags on each one of these items. And if I click on these items, it'll kind of jump to that section of the document and that I'm, for something that I may want to create. There's a couple in here that I really want to point out. So I want to go to this filter, and I'm going to unselect some of these. And I want to key in on these ones that says model. And the reason I want to do that is because not only is it breaking things down and saying, hey, this should be a requirement, but it's also breaking them down and identifying where and when models would be beneficial to my process. So if I look at this one, it says, yeah, this is a requirement based on what the AI says. It contains specific shall requirement statements in here. So based on that prompt, it's saying this is probably a requirement. But it's also saying, you know what, this looks like it could use a model table, or what we currently call a value table, because there's certain measurable items within this document that we could turn into a model. And so it's flagged that for me. Now, so the lower right-hand side, I can see that. I can see what AI is summarizing for me, and I can make that determination of, you know what, yeah, this is something I should create a knowledge packet of. And so if I look in my upper right corner over here, I have the initial suggestions for what a knowledge packet might look like. So if I look at it, it's kind of laying out a title. It's laying out all the parameters that I might want to use if I'm going to create a model table and include that in my requirement if I'm going to create it. And it gives me this option to create the KPAC. So let's do that. Let's just say create KPAC. I want to do this basic one. It brings in that information from the document. So if we look down here, it brought all that in. But importantly, then what it also did was, because I pointed it to a particular community of practice, that community had a bunch of metadata items that need to be understood in order to provision this information into your workflow. And the AI tool already went through and said, hey, I know what these things are. I found some of this stuff in this document, and binned it in here for me automatically for me to review and determine whether or not these are the values that, yeah, these make sense. These are going to get this stuff into my process. And if so, I can approve this knowledge packet as is, and I can say, yeah, let's save this. This is something I'm going to use in the future, and I'm going to create this knowledge packet. And so when I do that, it creates this knowledge packet in my community of practice up here, my demo community, and again, the power of live demos. And come on. We'll let that one continue to do what it's going to do, and I'm going to just do a quick refresh. So once you create you take a proposed item and you create it into something, it's no longer proposed. It is now something. And so if we look at this example here, this types and operational definition one, it had an idea of a proposal. It was a 6.734. But you can see when I verified it, well, actually when Terra verified this one, it shows us the link to the knowledge packet that was created that represents that information in that document. And so as the subject matter experts in this space, we can continue to work through this list, create the requirements that we need to create that we can then continue to reuse over and over again on recurring projects. And we can start to build up our knowledge repository with these model-based representations from the requirements documentation. So this is an example, again, of just the ingestion cycle. This is going basically from nothing to something. And how do we get to that point? And how do we get to that point efficiently? And through a lot of discussion and development and talking to all our customers, we believe this is the path forward for how to get that information in the tool quickly and make it something they can use. Now, let's talk about something a little bit different. There's that second cycle on there, and that was attributions. So this is actually when you already have something. So Terra laid it out. Basically, if you already have documented internal standards, if you already have these proxies or policies existing, and you want to point them back at the document and say, I already have this stuff, but you gave me this document that contains lots of requirements. Where does what I have fit into this document? Where do I have coverage? Where don't I have coverage? Where do I need to make changes or address items that I'm unaware of? And that's the attribution cycle. So let's jump back over here and do my attribution cycle. And for that, it's a different type of a cycle, right? Because I'm not going from nothing, I'm going from something. So I have an example of this one as well, and that's this top one here. So it's a similar process. I still run the document through, except instead of pointing it to a community that doesn't have any knowledge created, I would point it to a community that has knowledge created already. And what it does is it takes the contents of that community, those proxy policies, looks at that document and says, where do I have alignment? And it starts to identify. You can see now in my middle list here, I still have, on the left-hand side, I still have my document. In the middle, I still have all the proposed knowledge packets that the Cycles Composer is suggesting to me. But I also have these other ones where it's saying, hey, I've identified something here. And so if I click on one of these identified items, that it tells me that it's identified that this particular existing knowledge packet, Sunroof 18, kind of aligns with what's in the document. And it kind of shows stuff up in the green over here of where it aligns to. And so now, if I'm doing that process of where I'm trying to manage my internal stuff to the external stuff, and I'm saying, where does this stuff fit together? I no longer have to manually go through and find this information. I can use the Cycles Composer to say, identify all the areas where I have similarities between my internal and external. And then as a subject matter expert, it's just my job to verify it. And so it's done its job of identifying them, but now I can come in here and I can look at the contents of the requirement stock on the left. I can look at the existing knowledge packet on the right and whatever it contains. And if it's a good attribution, if it is accurate, I can say, yeah, this is a good one. So I can say, yep, this is verified. And once I do that verification, what it does is it puts that link or metadata tag on that knowledge packet back to this document. So if I want to know down the road, I use Sunroof 18 and I verified it for this particular project, where does that fit in my requirements document? I have that link back to my document now. It's stored in this knowledge packet.
And it's not just the document in general, it's that specific green box in the document, which is, we think, really critical.
So this is an example of the attribution cycle, being able to take knowledge packets like on the right-hand side. These are the existing ones. It points back to the document, and then it allows us to go through and verify that information. And if we continue to go through, another thing kind of I didn't mention is, let's say I go through here and I say, you know what, this one's not applicable, or I refute this one for whatever reason. We can improve our results the next time maybe this Kelsey Motors Inc. gets a revision, comes in the second time. Well, we can learn from what we did on the first time and get better results for how do we align the revision to our existing standards the next time I run this document through. So it kind of learns from what we're doing as well. So those are the first two cycles in the cycles composer that we have developed so far. The ingestion cycle, where it's proposing, the attribution cycle, where we're looking at internally created proxies that we're pointing back to a document, and we're allowing subject matter experts to go through and verify this information. But Terra showed a third wheel, right? The learning cycle. And although we don't have it embedded into this tool set yet, we're planning to put it into the cycles composer. And I want to give you a little example of what that is, so you kind of have something to look forward to.
Before we do, though, can you show one of the concerns? This is really cool. So that we've actually, through our experimentation, the AI with the prompt engineering we've done is actually really good at identifying issues in the document that's coming into the system.
Yeah, so that's a good point, Terra. I didn't bring this one up. So one of the things that happens when it brings in this information and shows all these suggestions in the middle is we'll identify, yeah, I found this suggestion, I'm proposing it to you, but I'm also warning you if you create anything, you create this. And if we look here, the concern that Terra mentioned, there's this little red box down here, and it identifies the number of concerns that the AI tool has with the content of this requirement, or yeah, this is a requirement, this one. And if I look down in the lower right corner, it shows me what concern this has. And basically what this one's saying is that this document is referencing a section for supply voltage and another section for glass reversal requirements, but neither one of those sections exists inside of this document. So it's referencing things that we don't even know what they are. So if you need to create a requirement from this, be warned, you're going to have to go out and do some investigative work and find these other items because they don't exist in this document. And so each one of these kind of has the same thing. If I click on each one of the ones with a red box, in the lower right corner, you can see my concerns that pop up for each of the items.
And then on the attribution side, when it's looking at that attribution, instead of a concern with the original document, it's going to highlight where your KPAC that's been attributed actually conflicts with the document, right? So do you have a non-conformance or a conflict versus a conformance? Because you might have an attribution that covers that same material, but has a slightly different minimum value or a slightly different maximum value. You need to understand where those differences are.
Let's hop back over here and let's talk about a learning cycle. Show some of the opportunities that we're working on. So I've come back to my Smart Tiles page. I have this tab down here for learning cycles. I click on my learning opportunities here. I have one that's it's still forming. So I'm going to click on this number one that's forming. In this particular learning opportunity comes, so going back to those circles that Terra laid out, we have ingestion, we have attribution, and we have this learning opportunity where we're actually using that information, we're using that knowledge, we're using those models in workflows, and we want to understand, when we're applying that information and those models into workflows, where we're encountering gaps. What can we learn from applying that information in projects? And so we have this tool that's been in the tool set for many years, maybe 10 years now, I don't even remember, called learning opportunities, or what will be called learning cycles. And what it can do is it can go through and it can collect clusters of, in this case, what I'm looking at now is are issues that have been created. So if I've used these models on a project and someone's created an issue from applying that knowledge into their workflow, we can kind of learn from that. And so this one is starting out with a cluster of issues. If I click on this little ID, it shows me what issues they are. So there's 2 of them. So there's 2 issues once this thing loads. Anyway, it should load here in a minute. But there's 2 issues that come up based on these axle seals. And what we're doing now with the ability with Gen AI is to look at these clusters, whether they're clusters of knowledge packets or clusters of issues, and use the AI tool similar to what we're doing in the Cycles Composer to say, what's similar about these things and what's different about them? What should I care about? What's the so what about this cluster that can lead me to an outcome where I can help to fill that gap, fill the void, and make sure I don't repeat these errors over time. And so I can look in here in this, hey, there it popped up. These on the left-hand side, I can see it's telling me, well, hey, here's the differences between the 2 issues. And it's also telling me here what's the same. Now I can look at this and I can say, well, you know what, this is something that should be addressed. And I'm not the one to address it on my own. So let me look at who the Cycles Composer or Learning Opportunity Cycle proposes I should include as team members. So I click on the next tab here, it's pointing out people. So it's got a collection of other subject matter experts that have some sort of relation to those issues or knowledge related to those issues. That's suggesting, you know what, I should include these people as part of a team. So it'll go out and invite those individuals where they can opt in to be part of the solution or not. Maybe they don't move on, they don't need to be part of the solution, so that they can opt out of it. So you can see that Josh and I have opted in to this process here. You can see we've opted in and we're waiting on others to opt in as well. So if we want to continue to kind of go through this and we want to create a solution, maybe fill some voids, we can look at what's related to those issues. Where do they come from? And I don't know if it's the internet or what, but this is really slow. It should come up with a list of knowledge packets that are related to those issues, and it does. It will show up in a minute. And based on that, based on the items that it's identified, it can also start to identify conclusions. So we can use the AI tool to say, there it goes. What should we conclude from these issues? It knows all about the issues, and it shows us the differences and the similarities. It knows about all the relevant knowledge within the tool that we've created, the models that we've applied, the workflows we've applied them to. So based on what it knows about what we've done with this information, how would it go about solving these problems? And it developed these insights. It says, well, you can create 4 new knowledge packets that will address those problems, and it's showing those there at the top. Or it says, you may want to just update 2 of them that you already have. You can modify some of that information in your tool set to avoid some of your problems. So let's say we decide to go with, hey, we're going to create new stuff route. If I click on my little button here, it shows me all the proposed new K-packs that it says I may want to create to then fill those voids to make sure we don't get recurring mistakes in the future once I have this information in place and then embed it back into our processes. So kind of to summarize a lot of the stuff we've gone through with the Cycles Composer and to kind of tie it back to AI, there's a lot of features that we've gone through that are using AI in the Cycles Composer. There's a lot of features we can apply directly into our tool set, into the authoring mechanisms, into the search, find, and X protocols, into what we can do within an assessment control when you're using assessment controls within your processes. And our plan is to do that. I mean, we've already developed the technology. Now it's just a matter of where we want to implement that in the tool, where it makes the most sense at this time. So if I hop back over here, and kind of conclude with where we're at with our generative AI features or AI features in general, right? I've talked a little bit about that search, find, and X, the generative search mechanism in the tool, and we're looking to expand its capabilities, making it much more comprehensive, much more ChatGPT-like. So when you get those results back in the tool set, you can continue to interact with that information. We're also looking to expand the write assist. So we've already, I think in the next release, Josh, we're binning the ability to do write assist within knowledge packet chapters. And we're looking to take that even farther in the upcoming releases as well. Some of the other things we're looking to do, and this is a big one for us, but we've seen a tremendous amount of improvement, is to get rid of the existing proximity search and replace it with an LLM similarity search. Our initial testing, we get so much better accuracy and relevancy with a LLM search than we could ever hope to do with proximity search. So think about that when you're in the middle of authoring a new knowledge packet, or you're working in an assessment or doing whatever, the ability of the AI mechanism to go find all the relevant items and then propose that to you in a much more accurate and robust way. We're also looking to start doing some more help content and maybe creating an agentic help bot to help new users get into the tool quicker. And another aspect that we've heard a lot, we've actually got this request several times, is for those of you that are doing kind of 8D type workflows and assessment controls, where you laid out your 8D process and you collect that, when you get to the end of that process, you've completed your assessment, you actually have an outcome that you're trying to do. You want to create a lessons learned or prevent recurrence, whatever it happens to be. And one of the things that we've been requested to do is create a mechanism that we can create and propose knowledge packets from the contents of that 8D that you've done in your assessment. As you can see, if we can do that with these requirements documents and we can propose knowledge packets, we can take that same functionality and apply that to an assessment control and generate with just as much rigor and robustness and accuracy into an assessment control to get you guys the knowledge packets you need for your lessons learned or prevent recurrence, whatever they happen to be. So we're looking to roll these things out. They're still in development. I mean, you can see we've done a lot of development in AI, but we're looking forward to what we're able to bring you in the future. With that, where are we at in time?
Thanks, Steve. Thanks, Terra. Any questions for Steve and Terra?
Ah, we did good.
3 minutes.
Oh, is it me? Okay. I just
Right.
want to
Wheels?
Oh, no, yes, sorry.
Yeah.
because this is a lot to unpack, and usually I've let you guys off the last couple years with my questions. So, but anyways, this one is really interesting to me because the ingester, this is the first time I've seen you actually do it in this conference. And I think, and I don't want to take anything away from the next presentation, but what you just showed actually can help us in the OEM world because we have roll downs of requirements, and I'm going to tell you, they don't match.
Yep.
I get a whole bunch of stuff from other people. They don't match. So I don't know for any other OEMs here, like this is one of our issues is I can tell you we've got multiple CAPEX that have multiple values or parameters from different groups. I'm sure Daryl can tell you that one because he's worked with our group on that. So I think, you're doing it internal, external, but it can be internal to, I think, anybody.
Sure.
Look
Yes.
across multiple,
Absolutely.
documents and stuff. I got a lot of stuff, but I don't want to take all the time.
No, go for it.
And now I probably forgot what I was going to say. But, I mean, this is a really good thing. I'm really excited to see this. And I'm really interested in the data ingester because I think I've got some stuff with that. But you've talked about PDF, Excel, and all those kind of things. I have a file that I cannot get into any of those files. So I need help on that one.
Yeah.
I can't figure it out. And then I think there's some opportunities that I know Jeff and I have talked about with the read across, and I don't know if anybody from Adient's here, but I know I have talked to Adient about what we talked a couple of years ago, because that's like, I think huge for us, because I'm in that seat world that Jeff's mentioned before. But I guess I'm just really excited about this, and I don't want to take all the time, so I have not gotten excited last couple of years, but this one, really, I'm talking. So we're gonna chit chat.
Excellent,
We
excellent.
appreciate that. Thank you, Nicole.
Thanks.
Hi, I have a question for you. When I think of the document and breaking it into small, granular digital units, I think about the end users, the consumers, the teams that aren't thinking of this as like requirements, but this is something that they have to read, they have to skim through, they have to search through. So I understand knowledge packets, I understand sets and assessments. What is the future to allow this document, when broken into all these small K-packs, to be readable and searchable as like a ensemble, or something?
Oh, so that they're recomposing back into the document?
Right, not necessarily to recompose back into a PDF, because you're starting back at the 10 years ago approach or 20 years ago approach. But what's the more modern looking approach for readability for teams that want to not have to search for all these individual K-packs on their own?
Yeah.
So we've had a little bit of discussion on this about how we're going to generate a report from the collection of all the different attributions or the knowledge packets that have been created that link back to that document. We haven't gotten that far yet, Carl. I mean, we're just at kind of this proposing the parameter stage. But it's something that we, go ahead. He's dying to
Jeff wants
talk,
to
so
talk.
hang on, he's dying here.
There's two things. What we see, the state of the art of technology, and we go to a lot of conferences. I've been really excited because we're ahead. So the state of the art of technology for specification decomposition is to shatter the document. So create a bunch of pieces, put metadata on them, and then go chase them all through the organization. That's what everybody's doing, and there's some really good tools out there, and Gen AI fits. But the advantage that we have is we have this 15-year history with symbolic AI and creating representations that are higher level, that are deterministic models, parameterized, that add the deterministic nature to that text, right? And so we are not only shattering, but we're reverse attributing, and we're also taking the first steps, as you saw, for model creation. We're suggesting the parameters, we're fitting the right parameters in. And when we get to when we add this was the whole point of my first presentation, when you add the symbolic AI part to the Gen AI part, you get this incredible uplift in capability. So what I would expect the user experience to be is to see parameters that thread across requirements that they don't see when they just see the shards of the specification. I expect them to be able to interact with the models at a parameter level instead of just reading and skimming. I expect them to be able to take those requirements and tie them to your LMS, your bench system, your CAD system, and have the parameters be connected to the digital systems that define those parameters, or actually compute those parameters in real time, so that they're interacting with a qualitative state of those requirements. Not just seeing, I have a fit-up force that of max of 100 pounds, when I can actually see that the device on the plant floor is actually put 98 pounds, right? And because of it's not a text I have to skim and go check on, it's something that's now connected. And this is where we get into that cognitive idea, right? The assessment has some ability to perceive context, right? And the language is now not just text, it's model-based. And so that leads me to the second point. So I think that the interaction model is going to be vastly different with a model-based cognition approach than it would be with just taking a large language model and shattering the spec, right? And we do see that is kind of Terra, the state of the art. We saw it. Terra goes to all these conferences with me, so she sees all these tools too.
It looks like right now we're significantly ahead of the curve, which is really exciting. It's also a little bit of a scary place to be, because our competitors are now starting to see what we're doing, and we'll see how things play out, but it is exciting.
No one else is coming at it from a model-based standpoint. And we're looking at all the players that you're thinking about, Siemens and PTC and IBM and all these tools. Errol's here. Hey, the last point I wanted to make is specifically because I made a huge claim in my presentation. I made the claim that model-based cognition is going to be disruptive to Tier 1 requirements. I don't think anybody doubts that I believe this, because I do. And the authenticity of the claim, I need to back it up. But I want to make sure that what you saw, I was asking Steve to put up those three circles: the ingest, the codify, and it's okay, I think everybody remembers it, and the deploy. The cognition, the model-based cognition part that's going to be disruptive to Tier 1 requirements isn't just the bit you saw, which was the import and the beginnings of the model. What we didn't demonstrate for you today, and as important, if not more important to the disruption of Tier 1 requirements, is the deploy using models. Because nobody's deploying requirements with models right now. I think everybody's talking about smart requirements. People talk about model-based requirements, but the barriers to entry there are high because you got to create models. You got to know what models to create. You got to have, people need to understand the value of those models to have the incentive to do it. And all these things need to be put together in one package. And here it is. This is it. And we do have a really good partner who's here today, who's pretty far down this path, and it makes me believe that this is going to be disruptive to Tier 1 requirements. So you saw the yellow, you saw a little bit of the green. We didn't show you the blue for model-based or for Tier 1 requirements, and all that together gives you the cognition.
So Carl, I would just add that, we are trying to go through the development of this feature set in a kind of strategic way, and you're talking about that very end piece. Obviously, like Steve said, we're not quite there yet. But one of the reasons that we're trying to pull customer pilots in so early in the process and bring them along with us as we go through each of these steps is because we realize that, based on the industry, based on your particular enterprise, you might need to consume these things in different ways, right? A lot of our customers use the assessment control, which does that dynamic provisioning, which creates this, kind of drill down just to what is applicable to that particular instance of you referencing the information. But in some cases, an assessment control isn't the best way for your users to be interacting with the information. And so when we get to that place, when we're at that point in the development of this recompose piece, right, we will be reaching out to all of our existing customers, say, hey, like who wants to help pilot this piece of it? Who wants to help build out for us all the different formats that really we need and the challenges we need to solve? And so what does that look like? Is it some sort of interactive document feeling thing, or is it something completely different? And that's so far with these first three pieces, that approach of reaching out in each and every step to different customers is I think, resulting in a really great product. So I look forward to working on that piece. I'm excited about that piece, but I don't have the answer yet because we haven't gone through those use cases. We haven't talked to the customers about it yet.
As you're going through this ingestion, as you're going through the ingestion, it's awesome that you give these warnings and cautions about different things that aren't lining up. Do you ever run into, or do you have the ability, do we have the ability to say, okay, this requirement or this request from the customer is not applicable to what they're asking us to do? Yeah. So Steve showed it very briefly, but in those options, that drop-down option that he had, one of the options was to say not applicable. And the idea behind that is that then you can persist. Hey, I'm the person who said it was unapplicable. This is my reasoning for why it's not applicable, right? Here's my unique identifier to that decision and that reasoning. And now when an auditor comes and says, hey, why didn't you do this thing? You just run a report and that comes up and says, hey, it's not applicable. And here's the person who did it and here's their reason, and all of that stuff is at your fingertips. You're not trying to recreate that documentation later. So I would go back to that strategy slide we were sharing at the beginning, where again, our overarching strategy is to surface the relevant information for you, the decision maker, to make the best decision as quickly and efficiently as possible. So it's not about the AI making the decision for you. It's about the AI providing you all the information, all the tools you need to make the right decision and have that decision be explainable and traceable. Yeah, so we're really focusing very hard on keeping that line between, providing information for you, but leaving that decision in your hands, so you don't end up with AI having done something, right, that now you're in hot water, you've got to go fix. You don't have glue on pizza, yeah.
Thank you, Terra. Thank you, Steve. We're going to cut it here. If you have more questions for Steve and Terra, they'll be available throughout the course of the day.